Welcome to Algebra 1 Honors. Today we're going to be looking at lesson 7-7, which is all about mixture problems. And there are two sort of general types of mixture problems, and we're going to look at an example of each one. And they're usually written as word problems. Okay, so you get additional practice solving word problems, which is a good thing. All right, here's our steps for solving word problems over here. Read the problem all the way through the first time, and then you're going to go back and read it again and again as you pick out different pieces of information. But don't stop. Read all the way through it. Figure out what's wanted. What's the problem looking for? Okay? Then you're going to, once you know what it's looking for, that's probably going to be your variable. Okay, choose your unknown, your variable, what you're looking for. Then make a picture or table, if it helps you, to organize your information. Write your equations, solve, and then check your answer. Okay, check your answer against the original problem, not by simply plugging back into your own equations, because you'll make the same mistake again. Okay? All right, we have a spice mixture, which is 25% thyme. How many grams of thyme must be added to 12 grams of the mixture to increase the thyme content to 40%. Okay, so what the problem is looking for is amount of thyme to add. Okay, so we'll write that down there so we know that that's what we're looking to find. All right, now, so our variable is probably going to be, or is going to be, the amount of thyme that we add. Okay, so let's put that right here. T for thyme. Okay, not X, because X doesn't remind us of thyme. Put T for thyme. Okay, try to choose your variables so that they remind you of what it is you're looking for. All right, so we've read it once, we've chosen our variable. Now we've got a picture or a table over here that is useful in doing mixture problems. Okay, you have your original mixture, what you're adding, whether it's a spice mix and you're adding thyme, a particular spice, and coming up with a new mix, or you might be working a problem where you have an original mixture of water and acid, okay, and you're figuring out how much water you have to add to get a new mixture which is diluted to a certain percent. Okay, so there are various versions of this kind of problem. But this chart is useful, this table in all of them. Then you have the total amount of your item here, the percent that it is, okay? And over here is the amount of thyme. So we're just going to multiply. Once you get this column and this column, you're home free. You just multiply straight across to get what goes in the last column. So we can look over at our original problem that says we have a spice mixture which is 25% thyme. So our original mixture, we can put 25% there. Okay? And then we have 12 grams of that mixture. That's also in our original problem. Now, we don't know how much thyme we're going to add, okay? But our new mixture, if we already had 12 grams, okay, in a big bowl, and we add T grams more, okay, or T grams more, what's going to be in our new mixture is 12 plus T. That's the total amount that's now going to be in our new mixture once we add T grams of thyme to it. Okay? And we want our new mixture to be 40% thyme. Okay? Now, the thyme that we add, thyme is pure thyme. It's not a mixture, so it's 100% thyme that we're adding. We're not adding a diluted version. Okay? Now we multiply straight across. 25% is 1/4, and 1/4 times 12 gives us 3. Okay? So we multiply straight across. And then 100% is 1. If you have 100% of a Hershey bar, you have one whole Hershey bar. If you have 100% of an apple pie, you have one whole apple pie. So this is 1. 1 times T gives us T here. And then we multiply across here. 40% is going to be 0.40 or 0.4 times 12 plus t. Okay? Now, this, the amount of thyme that was in our original mixture, plus the amount we add, has to equal the amount in the new mixture. So 3, we can say this plus this equals that. Okay? So we're going to write now, we've got our variables, we've made our table, our picture, now we're going to write our equation. And it's going to be 3 plus t equals 0.4 times 12 plus t. Okay? Now we have to distribute here, and we get 4.8 plus 0.4t. Okay? And on this side we still have 3 plus t. So let's see. Let's get rid of our 3 over here. We'll subtract 3 from both sides. When I do that, I'm left with t equals 1.8 plus 0.4t. Now, so that I keep a positive coefficient in front of my variable, I'm going to subtract the 0.4t from both sides. Subtract. So this is 1t minus 0.4t. Okay? And what I'm left with is 0.6t equals 1.8. And to find my answer, I take 1.8 and divide it by 0.6. Okay? My decimals each move one spot. And my answer is 3. So t equals 3. That's what the problem was originally looking for. How much thyme do we add? 3 grams. Now, let's see if that actually works. If I had 12 grams originally in my whole mixture, and I add 3 grams of thyme, that means my whole mixture now is going to be 15 grams, okay? And out of that 15 grams, the part that is going to be thyme is 3 from the original 12 grams plus the 3 that we added, or 6. So the part that is thyme in the new mixture compared to the total amount of the new mixture better be equal to 40%, which is 40 over 100. And now we can check real quickly. We'll cross multiply. We get 600 this way. We get 600 that way. And our answer works. Okay, so we've actually checked it, which is always a good thing to do. All right, now let's look at another type of problem for mixtures. Okay, this problem, same steps over here to solve it. It's a word problem also. Read it. Figure out what's wanted. So you have 100 kilograms of mixed nuts that sell for $4 a kilogram. You mix in some cheaper nuts that sell for $3.20 a kilogram. You want the new mixture to sell for $3.40. So you're trying to drop the price a little bit, okay, by mixing in the cheaper nuts. How many kilograms of the cheaper nuts should you add? So what we want to know is, I'll write it down here, how many kilograms of cheaper nuts. Okay, and we'll put our blank right there for our answer. Okay, so we're going to have, what we're going to be looking for, our variable, is how many cheaper nuts, what amount of cheaper nuts. So let's put that right there, C for cheap. Okay? Now then, let's fill in our table, our chart over there with our information. In our original mixture, let's see, you have 100, we have 100 kilograms. We're going to add some cheaper nuts. We don't know how many, that's what we have to figure out. So we're going to add C kilograms. So our new mixture is going to have 100 plus C kilograms, more than 100 kilograms. That's what we had originally. It's going to have C more. C turns out to be 5. We'll have 105 kilograms. Okay. Now the original nuts, the expensive ones, sold for $4 per kilogram. Okay. And the cheaper nuts sell for $3.20. So I'm going to use 3.2 there for 3.20. And we want the mixture to sell for 3.40. Okay, now once we get to there, we're home free, because again, we just multiply straight across to get what goes in the last columns. So 100 times 4 gives us 400 here. And then C times 3.2, well, that's 3.2 C. And then 3.4 times 100 plus C goes there. Okay? And now the cost of our original nuts here plus the cost that we add for our cheap nuts has to equal the cost of the mixture. Okay? So a lot of times you'll see this. You'll add 2 of the rows here to get the 3rd row. Okay? So let's do that. Our equation then is going to be 400 plus 3.2 C equals 3.4 times 100 plus C. Okay? This is the cost of our expensive nuts, our original ones. The cost of however many we add, the cheap nuts, added together equals the cost of our new mixture. This is the amount of our new mixture. Okay, now we have to distribute over here. And we end up with 400 plus 3.2C equals 340, all right, plus 3.4C. Now, let's subtract 340 from both sides. And we end up with 60 plus 3.2 C equals 3.4 C. Okay? Now let's subtract 3.2 C from each side. And that leaves us with just 60 over here equals 0.2 C. And so to find C, I have to take 60 and divide it by 0.2. Okay? This moves over 1, this decimal moves 1, so I have to add a 0, move this decimal over 1, and up, and then I have 2 into 600. And my answer is C equals 300. Right? All right, so our answer that we were looking for should be 300 kilograms. Now, let's double check. Let's go back to the original problem. So we had 100 kilograms of mixed nuts that sell for $4. So that cost right there, this cost is going to be $400. That's for the original nuts. All right, and then if we add 300 of the cheaper nuts, let's see, 300 times 320 gives us what? $960. Okay? And if we add those two costs together, 960 and 400, that'll give us 1360 total cost. Okay, but now we have to divide by the amount of kilograms in our mixture. Well, if we had originally 100 and we added 300, that means we have to divide this by 400. Okay, so we take our total cost there, our total cost of $400 from the original expensive nuts, $960 from the ones that the cheap nuts that we added. That's our total cost, but if we divide that by our 400 grams, that'll give us the cost per gram of our new mixture. Okay, so that's going to be 3 add a zero, $3.40. And that's exactly what the problem wanted. Okay, so our answer is correct. So we went back and checked by plugging our numbers into the original problem, not by simply recalculating. Okay, because odds are if you made a mistake, and we all do that, if you make silly mistakes, you'll repeat them if you just check by redoing the problem. Go back and take your answer and check it by rereading and filling in the original problem. Okay? So that's what there is to mixture problems.